length. This
Uh-huh.
S is probably the only one that's really weird. Why is it called the arc length? I don't know, but that is what they call it. And it's S equals R theta. You're like, oh, I got it. But theta is in radians. Radians. And radians are kind of like Celsius. It's like we don't really maybe fully understand it at first.
Uh-huh.
It is the same as degrees, meaning it's an angle of measure, but it's in a different unit, so to speak.
Uh-huh. So
Okay.
would it still be like 360 and stuff to make a full circle with it, or?
It is not. It is 2 pi to go around a circle. So
Okay.
so
All
what
right.
you're
I see
what
how that applies in.
yeah, what you're used to is you go all the way around, you're like, hey, that's 360 degrees, and I'm right. It's also 2 pi. They're both correct. Now, this formula is in radians, okay?
Hmm.
So we're going to use this formula for this problem here. So let me reframe it here. So you're going to start with S equals R theta. So 12 is S, radius is 6, theta is unknown. So theta equals 2, or 12 divided by 6, which is 2. And that answer is 2 radians.
Hmm.
Okay, now you should not do the following, but let's just calculate it in degrees. Have you done the conversion to degrees?
I have not. I didn't actually know that's a thing.
Okay. Oh, that's interesting. Well, we should do it because you will see it at some point. The um, the conversion is you multiply by 180 divided by pi. So do you have a calculator handy?
I do. And I'll also open up the Desmos calculator as well. Can you still hear me?
Yes. It
Okay, sorry. I
sounded
didn't
like
know
you
my
wanted.
Wi-Fi's been pretty off recently, so
Yeah, it's just make sure you get about the same, about 115 degrees.
115 degrees, 2 times 180, 180 divided by pi. Yeah, I got the same answer.
Okay.
I got like 114.6 in
Right.
specific, but
But here's what they want. They want you to write 2 radians as your answer.
uh
All right. So this is where you're going to have to commit to this right here, not the degrees.
mhm.
Okay, so let's look at another problem here.
How much does it grow from like kind of this simple problem? Because like we were just told about it today, and
I
then
I believe on your test here they do test you on radian and degree. So
mhm.
meaning like from past students, seeing their tests, seeing they ask you a question like convert or show two two radians on the unit circle, and you got to
Uh-huh.
know where that is. So we'll get there. We'll get there. And your work here is good. Your only thing you're really missing is the formula. S equals R theta. 36 equals 27 times theta. Divide both sides by 27. Theta equals 36 over 27, or 4 over 3. But it is in radians. You have to say it's in radians. It's much like giving
Mhm.
units of measure. It's 4
Yeah.
thirds radians. Now, again, like just for sanity check here, like what is this in degrees? Because we know I mean, I don't know, I'll just say like 40-ish degrees. Like this number
Uh-huh.
better be about 40, not 140. Okay.
Yeah.
So go ahead and calculate that, and let me know what you come up with.
Um, About 76.
Yeah. No, so is that, does that look like 76 degrees? I don't know. But this is the answer they want. They want that answer.
Um,
Okay. And
that's not
you gotta kind of get fully committed to going to radian. There's no
Mhm.
sort of like halfway in, halfway out here. All right.
Yeah, yeah. So, I guess my teacher never told me that. So I guess I'll still write that on my test. But all
Uh
I'm doing,
yeah, here's the more normal question. You know that there are 360 degrees in a circle.
uh,
And I just told you that it's also 2 pi radian. So it's like degree land and radian land. And it's like, well, what is the conversion? Well, it depends which way you're going. It depends if you're going from degree to radian or from radian to degree. Okay, so it comes from this equation I've written here. 360 times k equals 2 pi. If you divide both sides by 360, k equals pi divided by 180. Okay, so when you are starting from degrees and going to radian land, you multiply by pi over 180.
degree radian. Hmm. Okay. All right.
Okay, now we're going to go the other way, show you the calculation the other way. So let's say 360 degrees, you got 2 pi times k, and you divide both sides by 2 pi. K is now 180 over pi. So when you go
Mhm.
the other direction, when you go from radian land to degree land, you multiply by 180 over pi.
180 over pi.
This is what you want to remember. This right here. This is so critical.
Degrees. Okay, so degrees to
Radian.
radian.
Yeah.
So
IAN.
that's x pi divided by 180, and then radian to degrees, x 180 over pi.
Yes. Meaning multiply,
Mhm.
not variable X.
Multiply. Oh, right. Yeah. Sorry, my bad. So multiply by that. Multiply that. Okay. And I guess, yeah, that kind of makes sense because it's like one of them. It's kind of like division in a sense, where for going back. All right.
Okay.
I
Okay.
think I get that.
So let's
I'll
look at a
write that
really
down on a flashcard.
let's make a really simple example here. This is 0 degrees, and a right angle is how many degrees?
90 degrees.
90 degrees. So we're going to take our conversion here times pi divided by 180. What does this become? And you
Um,
don't use a calculator. You're simplifying by hand.
that would be pi over 2.
Pi over 2. So 90 degrees is also pi over 2.
Oh, and that's why all those problems, because it's like half the circle, sort of, right?
That's right.
Or it's kind
Now,
of
now this is 180 degrees. What is 180 times pi divided by 2? I'm
that
sorry,
would be
pi divided by 180. Sorry, I really messed that up.
all good. So is it just pi divided by
It's just
180?
it's just pi. Well, the 180s cancel, right? You always multiply by pi over,
Oh, okay, sorry, my bad. Yeah, they'd cross out. Yeah, so then that would just be pi.
right? And if you keep going, you go down here, this is 270 degrees. 270 times pi divided by 180.
That would
Yeah,
be 4 pi over 3.
3 pi over
Wait,
2.
sorry, why not? Yeah, 3 pi over 2. I don't know
Pi over 2.
what was going on there.
So what is it going up by each time? How do you go from, let me redraw it here so it's a little bit clearer.
I believe it's going up by 90 or 90 degrees or
In radian though, what is it going up by each time?
by 2 pi.
Pi over 2.
Pi over 2, my bad.
Pi over
Pi
2.
over 2. Right, yeah, because 2 pi would just be multiplying it pretty much.
So what would it be when you get to the all the way around the unit circle?
Oh, 360.
in
No,
rad
wait.
in
It
radian.
would
That's
be
what pi over two, pi over two, pi over two. What's another pi over two?
uh 4 pi over 2.
Which is two pi.
Uh oh, because it's like a half sort of, so it's like,
Four pi over two is four divided by two is two, so you got two pi.
okay. Could I almost look at those as like halves in a sense where it's like 1/2 plus 1/2 plus 1/2 plus 1/2 equals 2?
Yes, and then you just
Okay.
append the pi to it.
Okay, that's how I initially saw it.
So I believe this is the exam question they give you,
Hmm.
which is to determine where two radians is
Or 2
on
radiances.
the unit circle. It might be one or two radians, I don't remember. But you have to convert this to degrees. So what do you multiply by to go the other direction? So we go back to go from radian to degree, you multiply by
180 over pi.
180 over pi. Okay. So I want you to do that and give me a number here, please.
Um, like on a calculator.
Yes, yes.
Do I actually have to click like radians?
No, you just have to multiply by 180 over pi because
Okay.
it's already in radians. Like that's what I was trying to tell you. So the unit isn't really needed, but maybe it's good to write down.
Is it like 115?
Okay. Degrees.
More
Now
specifically, 114.6, but
that's close enough. So here's 90 and here's 180. Where should I draw the 115?
um, I guess in between them.
Somewhere in between, but closer to which one?
Closer to 90.
So this is two radians, which is 115 degrees, but they're asking about two radians.
Um, I'm not sure if I understand what
Yeah,
the
I get it.
question is, unfortunately. Because I
Yeah,
understand there's like the 2 times 180 over pi equals 115.
yeah.
But
You ever go to your phone and you're like, wow, it's really cold out. It's 0 degrees, and you realize you're in
uh,
Celsius.
yeah, I understand that situation.
And but it's no, it's 32 degrees F, right?
Oh right, yeah, freezing.
So
Oh,
this
oh
is
right, yeah, now that was quite literal. Yeah, sorry.
so in some ways it's literal. It's literally sorry, yeah, I get now I realize. So think of degrees as Fahrenheit and radian as uh
Celsius.
Celsius. Are they both true?
They are,
Are there places where like 0 degrees Celsius is 32 degrees Fahrenheit?
but they don't have the same numbers in specific, but they
That's
mean
right.
the same thing.
So we just did a problem where the answer is 115 degrees or it's two radians.
So
We
then
did
that
one
means,
we did one earlier where it's 90 degrees or pi
oh,
over two
so
radians.
we're gonna do the formula with it, right?
Well, you already did that. You already did. You
All
already
right, never mind.
converted. But do you see that these are the same? Like we did 180 degrees as pi radians.
Oh,
270 degrees was 3 pi over 2 radians.
um, so would we for 115, since that's a lot more specific, can we still use like 2 radians or?
The point is you can use either one. Like let's say you had a friend halfway around the world and he asked you the temperature and you're like, oh, it's 32. And he's like, oh, that must be really warm. And you're like, no, 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 it's really 0, right? Because he thinks
Uh,
you're in Celsius.
yeah, yeah,
Because 32 Celsius is pretty warm, believe it or not. I mean, it's like 110 degrees Fahrenheit. It's pretty
yeah.
pretty warm. Um, so what you have to realize here is that these are the same. These are totally the same. You ever met
Mhm.
someone who's a military person and they tell you right now it's you say, oh, it's 8:24 p.m. They're like, no, it's not. They say it's 20:24
Uh-huh. 2024.
because they're using military time. Military time goes from 1 to 24
24,
or
yeah.
0 to 24.
Oh yeah, I guess 0 to 24. I didn't think about that.
And they don't, and like if you say let's meet at 2, they're gonna say no, 1400
1400. Yeah.
because that's 2 in the afternoon. 1400 is so the point here. This is something really uncomfortable for every student. So every student's going to have this happen. You have to realize that you can give an angle in either degrees or radians, and they're both the same.
Both the same. Huh. Okay.
Think of it as like currency. You're in the business world. 1 US dollar is, I don't know how many euros right now, or how many pesos or
20
yen.
pesos. That's how all I know. 20 pesos.
20 pesos, right? So someone asks you how much they cost, you say, oh, it's about, it's $5 or 100 pesos. You have to know that they're the same.
Mhm.
You have to be
So
okay.
that's okay. Sorry, go on.
No, no, go ahead, make your point, or make your question, or ask
Oh,
me.
so like if you scroll up just a little bit to kind of like so like 360 is 2 pi radius. Pi radius is 90 radians. Sorry,
Radians. Radius is different. Radian, yeah,
radian. So then those are like really normal numbers.
that's
Or
right.
they're like you'd say like they're like nice numbers.
Exactly. They're nice. They're friendly. What is not friendly is 2 radians because it doesn't
Uh-huh.
really match up to it. Is 114.7.
6.
Yeah, that's not good.
Yeah.
But these
So
ones are
then,
perfect.
so when it's not perfect, then what are you supposed to do?
You're using a calculator, so either way, you can either
So
get
would I use like one of the formulas given before where it's converting? So it's like it went from what was it? It's like the thing I said I was gonna write as a flashcard after this lesson. The
the
two things
the
the
conversions.
formulas.
Yeah, right here.
Yeah, so did we just go from so we just went from degrees to radian, right?
And radian back to degrees.
And now we have to go radian to degrees.
We could. Yeah.
But that's just gonna give us the same answer, correct?
Well, if you go forward and backward, you will get right back where you started.
Yeah, so there's no point in doing that.
Right. But you have to understand the other thing. Like if I give you a number, like let's say I say it's 100, I say, what is 120 degrees in radians?
Then I would have to write like 120 times pi over 180.
Yes. So this becomes 2/3 pi.
And then that would be
Now let's go backwards.
2/3 radian.
Radians. Yeah. What is 2/3 pi radians in degrees?
You would then have to write that times 180 over pi, and then that would give you
Go ahead,
uh,
go ahead and
something you'd
calculate.
want to do on a calculator. I'll do that right now.
Okay.
All right, I'll start typing that in. Oh, that would be 38.238 and
Try again.
just overall.
You've got a mistake somewhere in there. Go ahead and try that one more time.
Oh, do I have to multiply that 2 by pi?
Yes.
My bad. That's where the mistake happened. All right, very far off. That would be 120.
Are you surprised by that?
No, because we know that 120 times pi over 180 because it's the 2/3. So therefore, if you like switch it in a sense, then it'll be 2/3 would eventually make it go up to 120.
So you went forward. You went from degrees to radians, radians back to degrees. So you should get what you started with,
Yeah.
and you do.
And then that shows how they are the same, even though they're the same, even though they're different numbers, but it's like the degrees and or Fahrenheit and Celsius.
Yes.
Okay, that makes a lot more sense to me now. I didn't even know there could be something like that for math.
Yeah. All right, let's try this one. Convert
So could
135
I
degree.
actually could you scroll up real quick just for the
Sure, sure.
formulas? I want to write those down just so I don't.
Yeah.
So it'd be like number times pi over 180 equals, and then do I know it's 120 just because they give it to me?
Yes, because you've already gone forwards and then backwards.
All right, and then the other one is 2/3 pi times 180 pi equals 120 degrees. Okay, all right, thank you. I got those written down.
All right, so I want you to convert 135 degrees to radians.
All right, one. So then that would be the number times pi 180, correct?
Yes.
Times
So,
pi.
so this is where if you go to the calculator, you don't put the pi in. And your calculator, just do the 135 divided by 180 in the calculator. Because it will reduce that, but it will not reduce it when it's
135 over 180 times
yes.
pi. That's the more logical way to do it.
Yes.
All right. I'll start typing that in. 135 divided by 180 times pi. Oops, I formatted that wrong. Times 0.1. Like 2.3?
This is a perfect fraction. Hit the fraction button.
The fraction, but 135 divided by 180,
Yes.
and then that would be 0.75.
Okay, so like 3/4 pi.
Oh, yeah. Oh, right. Yeah, sorry, I was not.
Okay.
Yeah, 3
So,
over 4.
all right, so
And
now
then
convert 3/4 pi radians to degrees.
and then that would be using okay, so we're gonna use fourths times pi over 180. No, 180 over pi.
Yes.
So then that would be 3/4. All right, I gotta type that in. 3/4. And then, 3 is getting multiplied by pi.
That's right.
Times 180 over pi. 180 divided. That gives me 135.
And are you surprised by that?
No,
That's just true.
because it was already there.
Yes.
Okay. I
All right.
think.
So let's move to a new topic here. We kind of, I mean, we did a nice dive into that, but we should spend, we're getting a little bit further away from what you maybe wanted to. Where
Oh,
where else should we go here?
um, I could go for maybe the Geo Unit 5 test review part 2,
Okay.
just spin cosine tan again,
Okay.
and just kind of apply those into the triangles as well. Maybe just do it in order, honestly, I think.
Sounds good. All right. You'll definitely need a calculator for number 4 here. So with this one, you are solving for X. Okay. You're solving for X. So what is keeping X from being by itself on the right-hand side?
Um, Sorry, could you just say that one more time? That
What,
just
what,
like went through my head.
what is keeping X from being alone on the right-hand side, from being by itself?
Um, I guess the fact that it's getting divided by 18.
So we undo that with multiplication by 18 on both sides of the
So then
equation.
that would be
18 sine of 40 degrees equals X.
and then that would
So I want you to go to your calculator and very carefully type in 18 sine parentheses 40 close parentheses.
18. And this is not the sine with the -1. This is just normal sine.
Normal sine.
18 sine 40. Oh my gosh. I'm doing it on the Desmos one right
That's
now.
what that's fine. Yeah.
And then 11.5.
57. Yeah,
Yeah, 57.
11.57. Good.
Then would it make more sense to say 12 or 11 in this case, or just
It
11.5?
says to round to the nearest hundredth. So just keep that in mind when you're going to round to the 2 decimal places for this one. It says that in the problem. It says to round to the nearest hundredth.
Oh, so then that would be 12.
Hundredth, 2 decimal places.
Oh, sorry. Yeah.
Yeah. It's okay. I know it's late.
I'll blame the time. I'll blame the time.
All right, let's look at number 5 because it's kind of related to number 4. This time though, the variable is in the bottom.
Mhm.
And this is the harder case to solve for. You are essentially going to multiply both sides by X. Okay. So on the left, X cosine 52 equals 19.
Mhm.
Now, what I think is frustrating or hard to understand at first is this cosine 52 is really a number. It really is literally, it's like 3 or it's like a 1 point, whatever it is.
Yeah,
It's a point, it's actually a decimal, but
it's a
it's
real
something.
thing.
It's something. Like it's not, and so you can divide by that something. You can divide both sides by cosine 52. So X equals 19 divided by cosine 52. So go to your calculator again and work that out, see what you come up with.
Cosine 52. That would be 30.86.
Yes. Now, very important comment here to make is to make sure your mode is in degrees on your calculator at school. You mentioned, I think you mentioned last time it was in your locker. That's fine. If you're not sure what I mean by this, ask your teacher, ask a friend, make
It's like
sure.
there's like a button that says like second or something on it that
Yes.
does it like that.
Yes. So it just keep that in mind, because you will sometimes get an answer that appears reasonable, but is completely wrong because you're in the wrong mode. So far you've been fine. Okay. All right. So number 6 here. All right. I want you to try solving this one on your own. Ask me questions if you're unsure.
All right. Uh, 62.
So round to the nearest hundredth. So again,
62.08.
all right, sorry, I didn't quite have it.
0.10. Am I correct? I don't know.
I'm sorry. Yeah, I just didn't have. Yeah, 62.08. Yeah, I just didn't have
Okay,
it.
my bad.
I was looking
Well,
looking
good.
through the
I
rest of
had
your
the exact
assignment.
same thing on like the last problem.
So, all right, cool. Okay, so number 9 here. This is a fairly standard test question. They'll give you a triangle. The triangle will be missing one of the sides. How do you find the missing side in a triangle?
You have
Right triangle.
to a squared plus b squared equals c squared.
You got it.
Awesome.
This time A and B are the legs, and C is the hypotenuse. So if you can go ahead and calculate C for us.
And then I have a question. So how do you know the difference with a, b, and c again?
So A and B are always less than C. A and B are the legs. They come out from the 90.
So does it matter?
You
It
can
doesn't really
choose
matter which one's which necessarily, right? For a and
that.
b.
You can switch them. Yeah.
And then c is just always the biggest. And in
Yes.
this case, we don't know what c is. So then a squared, 24 squared plus 7 squared equals c squared. 24 times 24, 16, 9, 8, 4, 6, 17, 576
That's C
plus
squared. Yeah. So you want to take the square root or plus the 7 squared.
plus 49 equals c squared, and then 576 plus 4, 9, 15, 8, 12, 625 equals c squared.
Yes. So what is C?
Um, I'd have to square root 625, correct?
Yes.
I'm just gonna use my calculator for that part because I don't know. Square root 625. 25.
It is 25. Very good.
And then that would be, so now that's the hypotenuse.
Right. So now we can go and actually do the problems that ask for. So the first thing it asks for is the sine of A. So you want to identify A in your triangle. There's A. Sine is opposite over adjacent or over hypotenuse. So you probably saw this at some point in class.
Yeah.
I think they do it this way, but the way I've shown you is above, I think is a little better because it tells you where each one goes.
Yeah, I agree with that. It's a little bit better.
So sine of A, you need the opposite side over the hypotenuse.
Um, that would be 7.
Over?
25.
Yes.
And then
Let's do the cosine of A.
24 over 25.
Yes.
And then the
How about the
final one would
tangent of
be
A?
tangent opposite over adjacent. So it's 7 over 24.
Very good. Now we're going to do the sine of B. So now we're looking at the other angle.
So we'll be looking at the other angle. That would be, Oh, so that's what they mean, where it's like you're looking at it from that as the angle?
Yep, you imagine like you're almost like you're there. What's
Okay,
opposite?
so then 24 is opposite then,
Okay,
correct?
over. Yep, over.
Um, for sin, that would be
Sine.
hypotenuse 25.
It's sine. Don't you really want to avoid saying sin. I mean, I made a joke. That's
My
another
bad.
class.
Sorry,
Uh,
that's yeah. Sorry.
Sine. I mean, any it like it matters. You can't go into Spanish.
Yeah.
You can't use Spanglish in Spanish class. You gotta
Yeah,
conjugate your
no,
verbs and all that. Like,
proper terminology.
yes.
Um,
How about the cosine of b?
the cosine, so that's adjacent, so that would be 7 over 25.
All right. Now, before you go any further, what do you notice is the same?
Um, the hypotenuse,
The sine of a equals the
the
cosine of,
cosine of b.
and the cosine of a equals the sine of b. And yes, this is always the case.
Okay. I didn't even, excuse me. I didn't even realize that. And then is the
Tangent of b,
tangent gonna be the same?
it's unrelated. It's reciprocal.
Okay. Would it always be like kind of flipped like that, where it's like 7 over
Yes.
24?
Yes.
Okay.
Yes.
So like I could technically use that as like a speed hack on a test if I wanted, but it's
Of
better
course.
just to do it.
Of course. Yeah. I mean, it's a way to check, am I correct or not? Sure. All right, let's go to with wow, where is they 10 through 13 or somewhere else. All right, we'll go to 14.
Mhm.
So 14, you're given an angle. Relative to that angle, what is 20 and what is A? And your answers are opposite, adjacent, hypotenuse. Which is which?
You're looking from the 30 degrees.
That's right.
A would be adjacent and then 20 would be opposite.
So which trig function uses opposite and adjacent?
Um, shoot, sorry. Sine?
Tangent. So you gotta
Tangent,
so you
yeah.
gotta know your SOHCAHTOA.
So then A. So then that would be opposite and adjacent. So that would be tangent, and then so tan 30 equals 20 over A, and
Yes.
then
I'd like you
that
to
would be
solve that for A.
all right. Let me write this out. Uh, 34.6.
Yes. Very good. Units are in centimeters.
All right. Back
Yes.
to centimeters.
Yes.
Oh
So
wait,
read.
no, sorry. I was thinking of uh angle instead of the other one, or degrees or whatever.
Yeah. So let me really quickly run through this one. Um, Notice this one's giving you two sides, not the angle.
Uh,
So the tangent, let me write this here. The tangent of D equals 107 over 128. So when you're trying to find an angle, this is when you use the tan inverse that we talked about last time.
shoot. All right. Yeah, I think I messed up on my test then.
That's okay.
unfortunately, but
You get a chance to redeem yourself. So yeah, if you want to, you can do this calculation. Um, it ends up being 39.9 degrees. Um,
39.9 degrees.
so, but your focus should be on the fact though that you're given two sides.
Uh-huh.
In the previous problem, you're given an angle and a side. So if you're given an angle and a side, you're going to use sine, cosine, tangent. If you're given
Mhm.
two sides, a side and a side, you're going to use sine inverse, cosine inverse, tangent inverse, like that.
Yeah. Sine, cosine, tan. Side, side. All right.
All right. So we do unfortunately have to stop here today.
Yeah.
Um,